arrow is good.
Good morning. Thank you very much. Emily and I are going to be doing this as a tag team today in light of some of the new and exciting changes that have come about for the Lunar Mapping and Modeling Portal, LMMP. So LMMP got its start as a mission planning tool under the Constellation program, integrating a wide variety of data products from a number of current and previous missions. The beginning of this fiscal year, AES and SMD transferred the management of LMMP from the previous Lunar Quest program office to CERBI. Since that time, CERBI and Emily's development team at JPL have been working very closely to enhance the mission planning capabilities of LMMP, particularly in the regions of the lunar poles. We've also been working to enhance the utility of LMMP as a general lunar science tool and as a tool for public outreach.
LMMP features over 600 data products generated from data brought back from past and current missions, U.S. and also international missions, such as Apollo, Clementine, LRO, and Kaguya. The number of products continues to grow. The variety of products include regional and global DEM, mosaics, slope, rocks, craters, integrated hazard maps, statistical distributions, mineral compositions, as well as gravity models. These products can be browsed, searched, and also downloaded. They can also be viewed in co-registered GIS layers and in 3 dimensions. LMP also offers mission planning and scientific research tools for surface characterization and also analysis of lighting, hazard, and also slope that are pretty essential for future lunar missions, landing site selection, and also pathfinding. Okay, LMP, enables really clear views of very settled features on the moon. For example, you will have a much better visibility of the large shield underlying the Marius Hills as shown on the graph, rendered by the distance and the profile tools offered by the LMP. The following are the examples of various products based on the LRO data depicting the same Tycho crater area. This is a LRO angled camera mosaic. And this one is the LRO DEM color hue shade map. And this one is the LRO DEM roughness map in 15 meters resolution. And this one is the LRO DEM roughness map in a 3-meter resolution, so you can see the difference. And this one is a thematic colored slope map. Okay. This shows the DEM slope map rendered in 3D terrain view that enables you to basically experience walking across and also flying over the surface of the moon within the LMP. Here you can see a polar 3D visualization in the top image there, and then an example of bookmarking features in the lower image. In a nutshell, you can select a certain region on the moon and then bring in data products for multiple missions, in this case Lola from LRO and also the iron oxide from the Clementine mission. You can adjust the transparencies between the layers to basically optimally depict the ion distribution on different features of the moon and then generate a bookmark URL so you can share with your colleagues as well as get later retrieval. And you can even add your own layers to integrate with this ones and the other LMP layers.
When planning landings or surface operations near the poles, you encounter a number of challenges, not the least of which are the very deep shadows. And those are clearly shown here on the LMP NAC Mosaic image on the left that depicts the North Polar area in the crater Perry. What we've been doing is we've been working with our partners at USGS and the Resource Prospector mission to prototype abilities to better map challenging areas such as this. On the top right, you will see an elevation map that we were able to generate, and at the bottom right, you will see a slope map. These are the types of tools that will be very helpful as we start planning surface operations in areas such as this. Something new that will be coming out soon is an updated version of our wide-angle camera Mosaic. The previous version had a number of deficiencies that we are correcting here. The new version has improved coverage at the polar areas, improved coverage on the far side of the moon, and more consistent lighting amongst the various images composing the mosaic. So the sun angle remains more consistent across those images. We're also going to have a new version of our laser altimetry DEM from Lunar Orbiter. On the left, you can see the current version, and on the right is the new and improved version. For this demonstration here, we're looking at the region of the Hortensius domes that feature very low relief features, but with high detail, and they really do illustrate the improved characteristics of the new DEM that we're getting from Lola. We're also, as we speak right now, ingesting the terrain camera mosaic from the Kaguya mission. And also from Kaguya, we are currently generating a number of gravimetric products, including here you see an example of the free air gravity map from Kaguya. In terms of gravity, we are also ingesting data from GRAIL, of course. You will remember in Maria Zuber's talk yesterday when she talked about the Bouguer disturbances and how they help visualize mascons. This is how that's depicted coming up here in LMMP.
So in addition to continuously adding new layers to LMP, we have been improving our tools in terms of performance and also robustness. The new slope tools will be able to generate contour and slope maps of not only the central area, but also the polar regions. What you see on the left are the slope tools outputs of contour and slope maps in the South Pole Aitken Basin area, and on the right are the outputs for the Malapert area. Now we have a video that we would like to show.
It's going.
Is it going?
Mm-hmm.
Okay. We are currently also enhancing the lighting tool that generate light quantities on the moon using much improved ray tracing engine and also the mesh camera feature. Taking advantage of parallel processing algorithms, we are now able to significantly improve the tool's performance. The lighting jobs now can be completed in minutes instead of taking hours or even days in the past. What this movie illustrates is the eliminations of one lunar day around the Perry crater in the North Pole. Did it show?
Bullseye.
Right, okay.
Yeah.
Okay. Okay. Are the new work that we have started, including a touch table visualization interface? Also an extension of the LMP tools and features to support small bodies and Mars data. Generation of 3D printing models. And we already have an iOS mobile app that is available for free download from the iTunes stores. And soon the Android versions will be released. Please come join us at the LMP demonstrations in room 112. You can get your hands on the touch display and also the mobile apps. And you can see a demo of all the LMP features and also get a preview of the Mars and also the vista data visualizations. You can also take a survey to help us improve LMP and let us know what are the features and data that you would like us to include. We would like to acknowledge our NASA sponsors as well as our survey management team and also the JPL LMP development team. Thank you for the opportunity here today.
Hi, thanks for that great talk, and I was surprised to see the number of very useful data products that there are. So I'm wondering, for mission planning purposes, if there are teams or groups that are using an external tool for mission planning, can you take some of the data products that's in LMMP and export them for use in another software program or something like that, like GeoTIFFs or something?
Yes, you can download the data, and you can also we also provide API web services that you'll be able to program into your new clients or other programs to take advantage of the data that we provide.
One of the things that we're really looking at is the commoditization of data within LMMP. So while we have visualization tools, what's really important here is the data that we have and the great connection that they've established with PDS. And so the ability to serve this information to a variety of external platforms is very important. Thank you.
Thank you.